So in the first part of this booklet, we looked at the idea of pure substances and impure substances. How if you've got one substance by itself, it's pure. If you've got a mixture, it's impure. Now we turn our attentions to a problem where if you had an impure substance or a mixture of things, how would you get them apart? That's known as using separating techniques. So separating mixture into its individual parts, which is quite a common thing to have to do in the chemical process. So in your notes, starting on page 5 down at the bottom, you, technically speaking, have to cover 6 different separating techniques, which sounds like quite a lot, but as you look at them, a lot of them are things you've covered in when you're in year 8, year 9, year 10, so that should be quite familiar to you. So in terms of what you have to get from this, and what you have to be able to do, generally speaking, it's understanding the process, which isn't actually too much detail, but more likely it's about picking the correct process for a certain mixture. So if I give you a mixture of sand and water, in the exam, you'd be expected to be able to pick the correct separating technique to get sand apart from water. It's by understanding which technique is used for which type of mixture, because they're all different. So, first one we look at is filtration, something you looked at probably in the first week of year 8. Filtration separates an insoluble solid from a liquid, for example, sand and water. So if I give you a mixture of sand and water, it'd be a sludgy mess. If you pour them both through a filter, a filter paper and a filter funnel, the water would obviously go through, the sand would be caught by the filter. So you've got a wee diagram down here, which kind of explains that. A couple of keywords. There's your mixture of your sand and water. As you pour through, the solid that sticks in the filter paper is referred to as the residue, and the liquid which goes through the filter paper is known as the filtrate. So that's for an insoluble solid and a liquid. Evaporation is a little bit different. It's separating a solute from a solution. In other words, a soluble solid from a liquid. So a good example of that would be salt and water. Sand does not dissolve in water, but salt does. So if I have salty water, I can't separate it by filtering it. Because the salt's dissolved, it will get through the filter paper as well. It won't achieve anything. So the way I solve that, if all I'm interested in is getting the salt back, we'll look at another scenario where we might be able to keep the water. But for now, all I want is the salt from the water. I would just put in an evaporating dish, put it on top of a Bunsen burner on top of a gauze, and heat it. The liquid would evaporate, that will leave the salt behind. Therefore, I've separated the salt from the water. The next one might be a wee bit different or a wee bit new to you. Separating funnel. So a separating funnel is used to separate a mixture of 2 immiscible liquids. So that's a new term there. Immiscible liquids, it means does not mix. So liquids that do not mix together. You've got a really common example of that, which you can check yourself in your own kitchen. If you take some water from the tap, and if you pour any kind of oil, like olive oil or vegetable oil on top of it, the two will not mix together. If you hold it up, you will see there'll be 2 individual layers which are separate from each other. So you might be, in the particular scenario, want to be able to separate those 2 layers, get them back. Luckily, it's not that difficult to do that because they are sat in their 2 different layers. We just need to pour them off quite carefully so they don't get mixed up, so they keep in their 2 individual layers. We've got a special piece of apparatus we use in chemistry to separate layers of liquids or immiscible liquids. It's called the separating funnel. So what a separating funnel is, obviously it's quite hard to see it without seeing a real one in real life. It's a container with an opening at the top, which you can pour your mixture into. Once you pour your mixture in, it'll settle into its 2 layers. So you can see with the 2 different shades on the diagram, it might be oil on top, water on the bottom. And the way we get these separated is that this funnel is attached with a tap. So when you open this tap, very slowly the liquid will drain out. But because it's drained out from the bottom, it's nice and controlled, nice and smooth. So I can gradually just lower that liquid down into the beaker. Now the trick would be, whenever I am emptying the liquid out of the tap, I want to close the tap just before it moves into the next section or the other liquid, because I want to get them nice and separate from each other. So I open this tap, let it drain out into a beaker until it gets very close to that line where we're about to go into the next liquid, close the tap, change the beaker, and then open the tap again to get the next liquid out. So as explained in this little paragraph here, when the tap is open, the liquid with the higher density, the heavier liquid, starts to flow through the separating funnel into the container. The tap is then closed just before the liquid with the lower density starts to flow through. The liquid with the lower density, which is the one on top because it's lighter, remains in the separating funnel and can be drained into a different container to separate the 2 liquids out. So that's our first three separating techniques. Our fourth one is another one we've looked at before. It's called simple distillation. So distillation is a process we would use to separate a solvent from a solution. In other words, a liquid bit from the solution. Now, an example we would use there is maybe to get water back from salty water, seawater, which is very similar to one of the examples we looked at before, but different, and it's important that you're clear on the difference here, not get mixed up. With evaporation we looked at, we had salty water, but we were trying to get the salt back from the water. We weren't interested in keeping the water, we were able to evaporate it off. In a different scenario though, I might have salty water, but I might want to keep the water and not let it evaporate off. Therefore I need to use a different process. For example, if I'm on a desert island and all I've got is seawater, if I want something to drink, I want to separate the water from the salt, but keep the water and not let it evaporate off. So distillation is a process we use where we can keep that liquid once we separate it from the thing dissolved in it. Distillation looks complicated, but it's actually just two quite simple processes. It involves boiling followed by condensing, and they happen in two different parts of the apparatus. So in this container here, this flask, I've got, for example, it could be other things, but I'm going to say it's salt and water. Maybe it's seawater. What I'll do is I will heat that container, maybe with a Bunsen burner. What will happen then is that the water will evaporate and turn into steam. The salt has got quite a high boiling point or melting point. It's going to stay in the bottom of the flask, that's fine. But my steam is now risen from this beaker, this container. Now in normal situations I would just evaporate off into the air, but I've kind of contained this off here. I've got a still head which kind of connects these pieces together, and it's blocked at the top by this thermometer. We'll come back to the thermometer in a second. So that hot steam can only go one place, and it's down this tube to the side. This tube to the side is known as a condenser. The condenser's job is to do condensing. Remember, condensing means turning a gas back into a liquid. How it turns a gas back into liquid is it's very cold. Well, not very cold, but quite cold. How we make it cold is we pass cold water from the tap around the outside of that tube. So the tube is hollow, the steam can pass through it quite easily, but there's like a little jacket around the outside of this tube with like two holes in and out. I put tap water in this hole, it flows through that jacket and comes out the other side, so I'm constantly cycling more through this container and keeping it nice and cool. When that steam comes into this cool container, it's very quickly going to cool down, and once it cools down, it's going to quickly turn back into the liquid form. Once it's back into liquid form, it's going to drip and run down the inside condenser and eventually spill out into this container at the end. So by that process, I've managed to evaporate my liquid off, but keep it by turning it back into liquid in another place. The salt is now here, the water is now here, they're now separated, but I've kept the water. A couple of wee extra terms here, just a fancy word we use to describe the liquid that comes out the end, a bit like filtrate and residue. The word we use in distillation is we've collected the distillate, the liquid that's come through the distillation apparatus. You have to know that this is called the condenser. You have to know that you put the water in the bottom and out the top. That just helps it kind of fill up the container quite well. So in at the bottom, out the top. And the thermometer is quite important as well for two reasons. First reason is that it allows us to work out what liquid we've got here. Now I know I told you that this was definitely water. I might not know it's water. The way I'd be able to confirm it is actually water is I know that water boils at 100 degrees C. Therefore, as this steam is moving past the thermometer will probably read 100 degrees C. So it's a way of me telling what steam or what liquid was in this container. The other important part about the thermometer is the position of it. If you're asked to draw it or identify maybe a mistake in the drawing, the thermometer should be at that low position where it's just where the steam is going into the condenser. If it's too low, I'm not getting an accurate reading about what's going into the condenser. If it's too high, it's not accurate either. It needs to be at the position just as it's going from this container into the condenser. So distillation, getting a liquid back from a solution, it's two processes. You boil it, then you condense it. Now we move on to something that looks pretty much the same, confusingly, fractional distillation. It's got the word distillation in it, and it also has got a similar looking apparatus. However, it's got a slightly different use than simple distillation. So simple distillation, I was trying to get a liquid back from a solution of like a salt is often water. I would use this technique called fractional distillation if I'm trying to separate two liquids. Now you might think, hold on, we've done that already. We did two liquids with a separating funnel. That was two immiscible liquids which don't mix together. Other liquids do quite happily mix together. A very common example would be ethanol, which is alcohol, and water, because as you know from alcoholic drinks, they mix together to form one solution. So this is the way I would separate, for example, alcohol and water apart. So I can fill that in here. Now that is actually quite a difficult thing to separate because they're both liquids, you haven't got different phases or different states to work with. They're both two liquids mixed together in one solution. The only thing I can actually use is one property about them, their boiling points. Because they are different liquids, they will boil at different temperatures. So it tells me here ethanol, which is alcohol, will boil at 76 degrees C, but water boils at 100 degrees C. If they boil at different temperatures, I should be able to get them separated by heating them and boiling them. So if I put them in this container together, ethanol and water, and heat them, what should happen in theory is the ethanol should boil off first because it's got a lower boiling point. If it boils off first, it can go through the apparatus, go into the condenser and out the other end. After a little bit longer heating, then I should be able to get my water to evaporate, go through the apparatus, condense, and turn back into a liquid. I probably would switch the beakers over once I thought I got all the ethanol in and get a new beaker full of water. You might therefore be thinking, well, hold on, that is just exactly the same as distillation we looked at before. That involved heating something up, going through the condenser and collecting it. It is pretty much the same. There's only actually one difference. The problem with this apparatus here, simple distillation, it wouldn't work that well for separating ethanol and water. The reason it wouldn't work that well is the issue is when you heat up a mixture of liquids, in theory you should get a good separation of the ethanol boiling first, then the water boiling second. In reality, it's quite easy for them both to boil at the same time. They've got quite close boiling points. If I did it with this apparatus, what I probably would get at the end is the same mixture in this container at the end. In other words, they would both kind of boil off together. The difference with fractional distillation is this piece of apparatus here. It's known as a fractionating column, which is where fractional distillation comes from. It looks quite complicated. It is just a long tube which has kind of like lots of glass beads in it. The reason this bit's here is for one purpose. It makes it more difficult for a gas, a steam, to work its way to the top. So in other words, it's more effort for a gas to get from the container all the way to the condenser. That makes it better at separating out the two liquids. If I make a wee analogy here, if you had 10 people you wanted to separate, you might set them a race. If the race was just 10 metres across flat ground, they probably would be quite close together at the end. However, if your race was a mile uphill, they'll be much more separated out because it's harder for them to complete that race. Similar here, if I've got a really short journey for ethanol and water to get across, they both can do it quite quickly. However, if I make it much harder for them by putting this kind of like maze or obstacle course in the way, lots of beads they have to work their way through to get to the top, it will separate out a wee bit better. The ethanol fumes or steam or gas will get to the top much quicker or much before the water will. So I've gone into quite a lot of detail there. The important thing is just if you've got two liquids, use fractional distillation. Fractional distillation is the same thing as distillation except it's got a fractionating column. The purpose of it is it makes you separate out your two liquids a bit better because it's harder for the two liquids to get through that when they turn into gases. It gives you much more chance to separate them on the other side. So that's the first 6 separating techniques. There is a 7th one, chromatography, but it's a wee bit more detail required for it, so I'm going to do it in a separate video. So I'll do this for now.